In the triangle PQR, PQ is equal to 8 centimeters, PR is equal to 10 centimeters, and the angle QPR is equal to 70 degrees. Find the other two angles of the triangle correct to the nearest degree. So we're going to start off by drawing out a triangle and labelling it as PQR. So PQR. Then we're going to label the information we're given. PQ is equal to 8 centimeters. So PQ is equal to 8. And PR is equal to 10 centimeters. So PR is equal to 10. And the angle QPR is 70 degrees. So QPR, 70 degrees. So because we do not have a side and its opposite angle, we must start using the cosine rule. So if we had a side and its opposite angle, we could use the sine rule. But because we don't, we have to use the cosine rule. However, this will only allow us to work out QR. Okay, so we're going to label our triangles. So since we're using the cosine rule, and in the cosine rule, if we have a look at it here, a squared equals b squared plus c squared minus 2bc cos of a. The capital letter in the formula is a. So the angle that we're using has to be labelled as capital A. So 70 degrees is now capital A. And the opposite side is lowercase a. Then the other two sides, it doesn't matter which way you label them as the b and the c. So this is going to be lowercase b, the 10 centimeters, and this is capital B, the Q. This is going to be lowercase c, the 8 centimeters, and this is capital C, the R. So we let A equals QR, B equal PR, which equals 10, C equal PQ, which equals 8, and A equal the angle QPR, which equals 70 degrees. So we're going to use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos of a. So the A is the side that we're looking for, so we just leave that as a squared. We swap the b for 10, so we've got 10 squared. We swap the c for 8, so we've got plus 8 squared. Bring down the minus 2, swap the b for 10 with brackets around it, swap the c for 8 with brackets around it. We get cos of a, which is 70 degrees, so cos of 70 degrees. We can put all this into the calculator in one go. We get 109.27. And since that's equal to a squared, we get the square root of it, which is 10.45. So this is now the side QR. So QR is now 10.45. So I've drawn the triangle out again down here, and this time I've labelled the A as 10.45. So remember, we were asked to find the other two angles of the triangle. So now we have a choice of angle to find. And this is because once we find one of them, we can automatically find the other one by taking the two angles away from 180 degrees. So to avoid the ambiguous case, it's a good idea to find the smaller angle first. So this is going to be C, which is the angle P or Q. So the angle C here, which is P or Q. And we know that this is the smallest angle because it is opposite the smallest side. The smallest side is 8 centimeters. So since we have a side and we have an opposite angle, we can use the sine rule. So the sine rule is A over sine A equals B over sine B equals C over sine C. So when we're looking for an angle, we can turn the sine rule upside down, but we don't actually have to do that because once you substitute into the formula correctly and you cross multiply, you'll always get the right answer. But in this case, we're going to turn it upside down. So we're using the sine rule. So we have sine C over C equals sine A over A. So we only ever use two of the ratios. We could have written out the full formula, which would also include sine B over B. But when we substitute it into the formula, we wouldn't have had any information in that part of the ratio. So we wouldn't have used it anyway. So I'm not going to bother writing it out, but you can write it out in full yourself if you found that easier. So I have sine C over C equals sine A over A. And I'm using these two ratios instead of the sine B over B because I'm decided that I'm going to try and find the smaller angle, which is sine C. So technically, I guess I have that in my formula. The lowercase c is 8, so I have that. Sine A, angle A, 70 degrees, so I have that. And lowercase a is side A, which is 10.45. I have that as well. So I substitute into my formula. I swap the c for 8, the sine A for sine 70, and the a for 10.45. I leave sine c as it is, or I can call it sine x. Now I cross multiply and solve. So I end up getting 8 times sine 70, so that's my numerator, 8 sine 70. And then I'll have 10.45 sine c on the left of my equal sign, but then I'll divide across by 10.45 to get the sine c on its own. So I end up with sine c equals 8 sine 70 over 10.45. Putting this into the calculator, I get 0.7194 to 4 decimal places. I do not know the angle, so I have to use the inverse. So using the inverse function, I get sine to the power minus 1. And I open my bracket, put in 0.7194, close the bracket, very important to close the bracket, and I get 46 degrees rounded off to 1 decimal place. So I found one of the angles, now I need to find the other one, and all I have to do is add the 46 and the 70 together and take them away from 180 degrees because the angles in a triangle add up to 180 degrees, and I'm left with 64 degrees. So the two missing angles are 46 degrees and 64 degrees.